So far we have a set of training data with inputs and the desired outputs or labels, and the loss function tells us how off our network's predictions are from the actual labels. So now we can define the problem of training a network in terms of minimizing the loss function. A key point here is that the loss is essentially a function of the network's parameters, weights and biases. So training a network can be seen as trying to minimize the loss by adjusting these parameters. In other words, we want to find values for the weights and biases that make the loss small, reducing the error of our network and increasing its performance. But since both the network and its loss are complex functions, finding values that minimize the loss is not straightforward. A naive approach could be to randomly try different weights and hope to get lucky and stumble on a set of weights that minimizes the loss effectively. However, this is like finding a needle in a haystack and won't work in practice for real large networks. Instead, we apply an optimization approach called gradient descent. Imagine you are on a hilly terrain and your objective is to reach the lowest point. Instead of wandering aimlessly, you'd probably feel the ground slope with your feet and move downwards. This slope is analogous to the gradient or derivative. The derivative tells us the influence of a weight on the loss. Specifically, the derivative of the loss with respect to a weight tells us how much a minute increment to that weight will affect the loss. If we add a small amount to this weight, will the loss grow or shrink? By how much? The intuition is that once we know the derivative of a weight, we are in a position to update the value of the weight in the opposite direction of the derivative, which will make the loss go down. This is the key idea of gradient descent. This was a quick take from LLM Chronicles. If you enjoyed this snippet and want to dive deeper into the world of deep learning and large language models, just check the full episode in the description below. Don't forget to like and subscribe to support the channel and get notified of all new content.